Good afternoon, everyone, and welcome to our webinar, Accelerating Mission Outcomes, Optimizing AI Performance, and Protecting the Budget. We're so glad that you could join us today. Before we get started, I want to take a quick moment to introduce what we do here at Fierce Software. Fierce Software is a small, woman-owned, value-added reseller. We specialize in enterprise open-source software, market-leading DevOps capabilities, and secure data platforms, all with a strong focus on supporting our public sector customers. Our unique reseller perspective helps us understand your goals and technology challenges, allowing us to offer solutions from our extensive portfolio instead of just a single vendor approach. We set ourselves apart in the reseller market by consistently delivering on our core capabilities. We act as an innovation broker, connecting our customers with leading technologies and the smartest people behind them. We serve as a license manager, simplifying procurement and reducing administrative overhead. We focus on customer success, providing access to vendor-trained and certified professional services. And we prioritize customer enablement, offering workshops, webinars like this one, and hands-on events to help teams stay current and build real-world skills. At Fierce Software, we're proud to work closely with our trusted partners to bring innovative solutions to the public sector. One of the ways that we're doing that is through our Fierce Innovation Lab, a secure, hands-on environment built with Red Hat, GitLab, and Dell technologies. The lab allows teams to explore modern technologies and DevSecOps workflows in a realistic, mission-aligned setting. Taking a look at our agenda for today, here's what we have lined up. We'll start with an overview of Red Hat OpenShift AI, followed by a live demo. Then we'll explore how Redis supports AI architectures, including a chatbot demo. For today's session, we're joined with Jessica Emmons from Redis and Chris Mays from Red Hat. They'll walk us through how Red Hat OpenShift AI and Redis work together to help your teams process and act on data faster than ever before. If you have any questions at any point, feel free to drop them in the chat. We'll address them either during the session or afterwards. And with that, I'm going to stop sharing my screen and hand it over to Chris.
All right, let me go ahead and share my screen. Okay. So first, I wanted to give a quick introduction to where Red Hat fits in this AI landscape. And if I move on to the next slide, hopefully, there we go. As we know, the enterprises across the world, across the US, across DoD, are quickly embracing generative AI, and we're seeing it everywhere. Not just generative AI, all types of AI, agentic AI and predictive AI, all different types. And so where Red Hat has sit in the past is usually we are the place where those workloads run. And we want to continue to be that place in this AI world, along with providing the tools and capabilities and the ease of use that you expect from Red Hat products. And so the complexities we're going after and the challenges that customers have generally are surrounding the same place we saw with containers, where it's the cost, the complexity, how to control them. And we wanted to create tooling that allowed you to continue to do that on the Red Hat tools and capabilities that we already provide. And so with that, we have Red Hat AI, and it's a bundle of tools that work across the entire ecosystem. So we're trying to make everything fast and flexible. We want to connect you to data as quickly as you need to, help you with tuning and model training and all the things you would need from a AI model creation process. And of course, as Red Hat always does, is scale you across any hardware they happen to be running upon. And that could be further illustrated here. We're working with all the major vendors across GPUs, all the major clouds, and of course, we work across all of the hardware that you would expect, from physical to virtual to private cloud, sovereign cloud, public cloud, edge. We want to have you covered across all those bases. And so the products we're using here are fall in a handful of categories. First, we have Red Hat AI Enterprise. That's going to be a specific OpenShift SKU that allows you to get access to our inference server, OpenShift AI, and accelerators to run on top of OpenShift. So think of it as an OpenShift cluster specifically built to run AI workloads. And then we have our AI inference server, which is based off of VLLM. That is a acquisition we made in the last handful of, I believe, a year or two, where it is now becoming the de facto way to run models. And it helps, I'll go over it a little bit more detail later, but it helps run those models in a cost-effective manner. And then we have OpenShift AI, which is a set of tools that are running on top of OpenShift. I'll also cover that later. And then Enterprise Linux AI, that is if you want to do generative AI on your existing RHEL servers today, you have the ability to do that using Red Hat Enterprise Linux AI. So to cover a handful of those products, I want to go over Red Hat AI Inference Server first, because that is where these models are going to run. We want to be able to kick off models. We want to be able to do the RAG demonstration that we're doing later today. And we want to have a place to run that efficiently, and that is where our VLLM technology comes into play. It helps by being able to serve any of lots of different types of models, and it does it in a very consistent manner. Able to do it over CPU, over GPU, a handful of different ways of kicking these models off. It allows you to do model compression, making them smaller, making them cheaper, easier to run. Because at the end of the day, we know these GPUs are expensive, they're hard to get their hands on, and you want to make the most efficient use of them. That is where Red Hat AI Inference Server comes into play. And here's just some more things surrounding that. As I mentioned, it helps with the compression of models. Red Hat has come up with a set of certified products that have come out, certified models that you're able to gain access to right away. We have an AI Hugging Face repository that you're able to pull a whole bunch of those models from. And again, this works across all of our infrastructure that you're used to. And we're not just promoting our models, right? We work with all of the third-party open source generated AI models, and we want to show you that here, that we're working with all of them, and then that we got all the compression tools on the right here. And now my favorite, of course, I'm the OpenShift guy here at Red Hat for covering the Air Force and Space Force. So I really care about OpenShift, and this is OpenShift AI. So this is a set of tooling that runs on top of OpenShift. And I will be demoing that here in a second. But first, let's set the stage. As hopefully you guys know, with OpenShift is a Kubernetes cluster that is running on top of all of these locations down below, so physical through the edge, on any hardware, any cloud. And is a Kubernetes distribution that is making life easier for our users. OpenShift AI is yet another tool then that runs on top of that. And we come with a lot of the Granite models that IBM is producing. We have Llama Stack, which has actually just got a rename, and I'm forgetting what the rename of that is, but it's going to be something like OSX or something like that. I can't remember exactly what it's called. But anyway, there's a whole bunch of tooling that we're bringing with it. AI pipelines, things to help the users with their machine learning and pipeline and generation across the way here. We got Jupyter notebooks. We'll be able to show that off here in a little bit too. And so these are all the things that we are focusing on when we're focusing on OpenShift AI. We want to help you build your models, customize them, monitor them, serve them. We want you to make the best usage of your GPUs and the expensive hardware that you're purchasing. We want you to share them across your teams, be able to schedule workloads. That is where we're coming with when we're talking about OpenShift AI. This will be in slides that are put out to you guys. So if you want to, I'll pause it here for a second in case anyone wants to grab that QR code. This is a way of trying out any of our products. We have 60-day trials for all that stuff. And if you work with your Red Hat sales team, we could probably even help you further in getting that a more proof of concept or customized approach to getting you started on these with these products. And with that, I'm going to go ahead and switch my screen over to my OpenShift cluster. And so to do a quick overview here, this is OpenShift. This is our view into our Kubernetes distribution. And we could see we have the normal Kubernetes stuff. We have pods, deployments, stateful sets, all that good stuff you can see here from the GUI. And what I wanted to highlight today, though, is our Red Hat OpenShift AI. And by the way, if anyone has questions, feel free to type them into the chat. I don't believe you guys have access to audio, but if there's any questions throughout anything here, feel free to interrupt me and go ahead and ask away. And I'm sure that's true for Jessica as well. I don't think she's going to mind either. And so getting back into the demo now. So with OpenShift AI, this is our tooling that runs on top of OpenShift. It is run through, it is installed via operator. So that is just a way of installing apps on top of OpenShift. It's also how we installed Redis on top of OpenShift. So Redis has been nice enough to create an operator that runs in OpenShift, and that is how we were able to kick off the Redis DB that you're going to see today in action as well. And so through the OpenShift AI GUI, we work through different projects. So in this case, we have a RAG project that I created. We have an AI hub with a whole bunch of catalogs that have been curated for you to be able to kick off, a whole bunch of models that have been curated to kick off. And this allows you to then get started quickly, right? So you can kick these off and they're pre vetted to work inside of OpenShift AI. You can add your own registry. So if you're creating your own models or want to bring in models from another location, you can actually create a registry and go ahead and bring them in. And in our case here, we have two deployments already kicked off. One is the Llama 3.2, 3 billion model. This one is running, you can see on top of an NVIDIA GPU. So this is all running in AWS today. It is running on one of it's a node was added to the cluster that has a GPU. That is where this is running, and this is going to serve the LLM for our RAG demo that we're going to show you. And then we have an embedding model that also aids in the RAG. So this is what during ingestion time of the objects, this is what's going to actually go ahead and break it up and put it into the Redis vector DB. And then there's a whole bunch of other features in OpenShift AI that might be outside of scope of what we have today, but we also have pipelines for AI and ML experiments. We also have the ability to pull up Jupyter Notebooks, which I will show you today. So when we go into our RAG project, we do have a RAG Jupyter Notebook, and this is what Jessica was using to experiment as we were developing the demo here. Has Git, could get pulled in right away, and this is a notebook that is being used here. So this is all running. The benefit of doing this inside of OpenShift is that it's number one, running on all the OpenShift hardware, so all the hardware that's backed by that, which means it's a shared resource, which then allows your users to make better use of your hardware. So instead of having to divvy up hardware to different groups and then it's going to sit idle at different times because different groups are working at different times, let's share those GPUs, make them a shared resource, and make the best use of them. Let's keep them humming at 100%, right? That's the idea here. And I think that's going to cover everything for this. I'm going to go ahead now and stop sharing and hand this over to Jessica.
All right. Thank you, Chris. Here, I will share my screen. All right. Everybody can see it. Yeah, so like Chris, I'm going to go over how specifically Redis can be used in Gen AI applications, but specifically on top of an OpenShift platform. All of our largest enterprise customers are running their Gen AI applications with Redis on top of OpenShift. So we thought that this would be a great, combination since we're seeing this pattern so often in the market. With that, yeah. So the number one thing that like my goal today is to kind of get you all to understand kind of the why behind these numbers. Right now, Redis is the number one data choice for data storage for AI agents. And some may think it's kind of that classic Redis speed because we are the fastest vector database on the market. However, what I want to show you today is that it's because of Redis's flexible capabilities and technical implementations in terms of delivering context to AI applications. That's why we're starting to be used so frequently in this space. So I really wanted to start with some of the AI use cases that we're seeing in the market right now. We know that in the past couple years, when LLMs really started to um, get pretty smart, we saw a lot of chatbots emerge. Chatbots have been in the market for a long time now. And specifically now we're seeing them roll out as internal knowledge base within um, agencies, citizen chatbots to help understand kind of some disparate documents. But from chatbots, we've seen, and now we're kind of almost seeing this trend further into AI agents. And these are these autonomous workflows where LLMs can converse with tools, make decisions in the background, write code, that we're seeing agencies start to experiment and build out these applications, as well as kind of some places that stay a little bit out of the concurrent talks about these AI workloads are AI gateways, so ways to manage AI LLMs at scale, API calls at scale, AI assisted search for research discovery when you have uh, published research in different forums, different data sources. How can we use AI assisted search to help in that discovery? As well as these really high speed, mission critical applications like recommendations, next best action, or anomaly detection that require extremely low amounts of latency in order to catch things in a timely manner. Given that a lot of these AI workloads are so latency dependent, so accuracy dependent in order to deliver the success of a mission, we're seeing a lot of problems with old application architectures for delivering data to these particular applications. And this is kind of because a lot of traditional application architectures are disk-based legacy databases and a cache on top. However, in an AI architecture, so much data flows through these LLMs in order to allow them to make successful, accurate decisions that kind of these disparate, siloed, complex data stores can end up hurting the accuracy and performance of the application. As well, if you don't manage to mesh the proper amount of data, the proper context together, it can also lead to kind of wasted LLM calls trying to find that perfect context window to get the result you want. And finally, we know that these LLMs, the actual logic process of returning an answer is the bottleneck in these applications, or at least they should be, because there's a certain amount of time that these particular models need to make a decision. What you don't want is to add latency on top of it in terms of getting it the data it needs. So you don't necessarily want to be waiting for slow disk-based calls to your LLM in these really mission critical, high velocity workloads. And there's there's a couple reasons why context beyond just performance becomes really key in these stacks. And that's really because LLMs are becoming a bit of a commodity in that they're improving so rapidly. There's a new model every week, which was makes platforms like OpenShift AI really key in the market, is that you can easily switch out these kind of these LLMs based on what's the newest model, what's going to work best for your particular activity. However, I like to say that, if you give the smartest guy in the world the question, why is my DoorDash driver late? He's not going to be able to answer you because he has none of the context about your order, where it's coming from, what's going on in your DoorDash driver's day. So it's the same exact thing for LLMs. Delivering them the proper information at the right time is your context window, and that's the key to getting successful answers. So this is where Redis has really focused a lot of their development. And we've kind of come out with this real-time context engine that you'll see in the demo later in kind of a more simplistic chatbot manner. But this is a high-level, complex architecture that we're starting to see emerge in these mission critical workloads where you have advanced search, optimized LLM calls, long-term and short-term memory, and context delivery for various different data types from unstructured, structured data, agent states, all delivered through Redis through real-time syncing with backend data stores. So you can still have your ACID compliant data stores for some of this context, but the actual data delivery is happening through this in-memory flexible system in Redis. So to kind of ground that in more of a real life example, let's look at, the architecture for, like I said, that early use case for this technology, chatbots. So Redis is a flexible in-memory data store. It's traditionally used for caching, where now, because we have a full-fledged, very flexible query engine that has actually been in the product for a long time, but in combination with some of these traditional caching, session management, Redis techniques, now with real-time search, we get some really interesting technical implementations within AI architectures. Here's just an example in a chatbot, and I'm going to go through what some of these implementations are, both in my slides, and you'll see a real-time example in the demo later. So, we can be used within retrieval-augmented generation workflows as a document store, a way to optimize LLMs through semantic caching, or something that lends itself to Redis pretty clearly as we exist within memory. We're great for short-term and long-term memory within the system as well. Went the wrong way. So all of this is based on the Redis query engine, as I said. It's something that folks that are used to traditional Redis caching may not be very familiar with. But Redis has a full-fledged synchronous real-time query engine within the product that can do hybrid search, full text search, to vector search. Again, as I said earlier, we are the fastest vector database on the market. But we also have that flexibility within our search that really becomes the foundation of a lot of these AI technical implementations that help us solve some of the problems we're seeing in getting these AI applications into production. So the first of which, and I think is the easiest for a lot of our customers to grasp if they're used to Redis traditional caching patterns, is semantic caching, which is really just caching but with AI. So it is caching frequently asked questions or prompts to your agents or chatbots, and specifically caching the semantic meaning of those questions. I think the best example I have of this is in South America, the most common chatbots ask is hola. They always say hello to their chatbots. But that's fine if you're taking it at an MVP point in a lab, where maybe that's a couple cents worth of tokens. But when you put that at a full scale in front of millions of citizens and you're spending tokens on every hello, that can become a very high cost very quickly. So semantic caching is a pretty simple pattern to just very easily reduce those unnecessary LLM costs. We can see at certain, especially like citizen-facing chatbots, we can see up to 90% LLM cost depending on the scale. The next easiest one I tend to see customers gravitate towards is memory. Especially short-term memory, we see it makes a lot of sense within, a traditional caching software. Redis, though, has a pretty opinionated approach to handling agentic memory, as your memory is going to include your long-term memory, your working memory, your chat history, maybe some information from the specific user session that includes user preferences, etc. And the challenge becomes with memory determining how exactly to determine what long-term memory pieces are worth providing to the LLM at a certain time. We have a pretty opinionated approach to this. It's called Agent Memory Server, which is a RESTful API and MCP server. However, today I'm just in my demo going to show you a basic implementation of chat memory that was actually used by OpenAI in order to scale ChatGPT. But today is going to be kind of a simple example, but we are happy to work with customers on dealing with their more complex short-term and long-term agentic memory problems. And finally, I think the one place that people don't always think of it becomes a problem in AI applications is what do we do when it goes to scale? And very similar because LLMs are just an API, and just like APIs, you're going to need to have some kind of guardrails and gateways around them to for rate limiting, PII redaction. But in agentic workflows, that gets a little bit more complex because agents are necessarily choosing which LLM to call. There might be complex routes that you can go in. Where Redis, as you'll see an example today, I have a very simple implementation of a guardrail, but you can use Redis AI gateways for more complex routing from choosing the best LLM for a certain prompt or choosing when to actually have the agent go down a deterministic workflow rather than calling an LLM. So just again, today we'll see basic guardrail semantic routing, but at scale, you kind of want to add all of these things together to really protect your application from bloated spend and any security issues. So here, just to give you an idea, Redis, because we're really a part of the community and building out and helping developers solve that next AI application challenge, we have a lot of integrations within the space. For the sake of time, I'm not going to go through all of these, but basically, if you have a model, you know, running on OpenShift, et cetera, we're gonna be able to integrate with the tools that you want to use specifically in your stack. And this just a quick call out. We're talking Redis. We are similar to Red Hat. We have an enterprise and open source products. We recommend a lot of our government customers gravitate towards the enterprise product due to its high availability, scalability, and advanced security capabilities compared to the open source products. And I'm happy at any point after this to discuss with any of you kind of some of the specific when to use enterprise and what those differentiators are. So now I'm going to jump into the demo again to kind of put a pin in what Chris mentioned. This was all built on top of OpenShift AI, is deployed within an OpenShift environment using the Redis Enterprise official operator, and built with some of these patterns that I just discussed: short-term memory, semantic caching, vector database for RAG. So we're going to get to be able to see this in real time, but this entire development process is hosted on and was made possible through my development cycles on OpenShift AI. With that, I will jump into the demo. All right, here we have my extremely lovely UI. Where today's demo, I'm going to be showing just a example of a chatbot that gives information about active duty military family member benefits. Specifically, we'll be focused on military one source counseling for this particular example. As you can see, I pre-uploaded some contextual data of the military one counseling services guidelines, as well as a flyer. In a full-fledged RAG environment, you would include all of the different disparate PDFs, necessary kind of context, proprietary context for a particular program or whatever you want the functionality behind the chatbot to be. So the first kind of technical implementation I'm going to be showing you is that semantic caching, frequently asked questions. So as you can see, I have a baseline LLM window as well as the Redis Enhance window. So if you see the baseline LLM is just directly calling that LLM, that Llama 32B that Chris is hosting on OpenShift currently. And if I paste the same question, what is military one source, in one sentence, you can see this baseline LM gave a one sentence. And if I send to the enhance, you should get about the same behavior. Because it's an LLM, we might get slightly different wording, but both of these are calling directly to that llama baseline, that base LLM. Now, where semantic caching comes in is if you take the same question, maybe slightly different wording. Explain what military one source is. If I send this to baseline, the wording is getting the LLM thinking it's going to require a longer answer, as LLMs tend to go towards longer and over explaining themselves. So it took a little, it took a significant amount of time to get that response back and was a significantly higher level of tokens. Now, if we see in the Redis enhanced window, if we put the same slightly reworded question, it should, and it does, hit against the semantic cache because it says, okay, we've already answered this question with this semantic meaning. So you can see the response is significantly faster and it saves those particular tokens for the sake of, not overusing LLM spend. Now, this is an extremely basic example of this. And you can see, I will say, classic demo daemon. I realized last minute that these totals, the clear semantic cache does not clear those totals. So you'll see these totals are a little higher just because of testing when the environment was up. But basically, this is a simple semantic caching implementation, but in a production environment, you would tune this through your similarity threshold for cached responses, your time to live on these values, and picking specific embedding models, as well as in combination with some of these other enhanced controls, specifically routing, in order to kind of really tune this to make sure that you're only responding with a cached answer when appropriate. But again, at scale, caching those answers can, here you see pennies. At scale, this can be thousands of dollars due to how expensive these LLM tokens can get at scale. Now, the next thing I really want to go over is chatbot memory. How can Redis be used for short-term memory within a system? Now, here, let's take something like my father is an active duty Army lieutenant. If we send that to baseline and we send it to the enhanced chat, we're going to see similar to the beginning of the semantic caching example, where they're both being sent to the LLM. They're giving slightly different answers, but it's effectively the same behavior. Now, if we ask a follow-up question to that particular statements, which users tend to do, what resources would my dad have access to because of his job? If I send it to baseline, baseline doesn't have a form of memory right now. So right now it's trying to figure out what the heck I'm talking about. And you can see in this, it's going to ask me basically for more information about my dad's job because it has no recollection that I told it that my father is an active duty Army lieutenant. But if I ask the same question here, you're going to be able to see that because of the memory, because it is tracking 4 different terms of memory since I turned the memory on, we're going to get a response that is specific to an active duty Army lieutenant. Again, just grounding that more accurate information in by using that context through memory. Now, a user might eventually learn this has no memory and then adds maybe the context of what resources would my dad have access to if he is an active duty Army lieutenant. But the wasted LLM calls in the user trying to figure out what is the best way to get that accurate response is also a problem at scale, other than just, somebody would be quite frustrated and rather just try to find these PDFs on their own. With that, the next thing I'm going to focus on is RAG context. So LLMs are trained at a certain point in time, and they don't necessarily have the ability on certain websites to open up PDFs on websites, even if I pulled these from, a very publicly accessible place. And so a lot of times chatbots, AI agents are going to need to be fed with contextual proprietary information that is necessary for that specific point in time. So an example of this is these counseling services guides from Military One Source. So the best way to see this is actually kind of let's ask a question about how many sessions of counseling are offered through this specific program. Now, the baseline LLM is going to see that the program exists, but is not going to be able to get any further information because that information about the number of sessions is stored within these PDFs on the website, and the LLM does not have the access to read those. Whereas if we provided the RAG context within Redis, we can ask the same question of how many sessions of counseling are offered through the military and life counselors in the military life counselors program. If I send that to enhanced, it's going to check these files within Redis that were chunked and embedded within the Redis database for a similar question and answer us very succinctly with 12 sessions based on specifically the retrieved context. And down here, you can actually see some of these chunks that it's pulling this answer from. Now, when all of these together become really powerful is when you ask kind of more complex questions that involve memory and that context, like, am I eligible for a counselor through that program? We know this baseline LLM doesn't know anything about me, doesn't know what program I'm talking to. Whereas if we ask the same question to the enhanced model, it's going to be able to use semantic caching, memory, RAG context to give us an answer that is grounded in what it knows about me, that I have a father who's an active duty service member. So yes, I'm going to be able to be eligible for this counseling service. Now, the final kind of pattern for LLM cost savings that I want to go over here is routing. And like I said, this is kind of a small part of a large technical implementation that we refer to as AI gateways. But here I'm going to just show the implementation of a guardrail without necessarily having to hit some of these complex guardrail LLMs that can also require token costs. So an example of this is I set up a guardrail here to prevent kind of malicious, out of scope eligibility asks. You'll see in the system prompts, I do have a similar guardrail that I do tell the LLM, hey, don't ask things that are out of context. And it does block that. But as we know, LLMs, that block is questionable at times, and there are ways to get around them because of the very nature of these LLM models. And it also required token costs, where if instead you pull that routing logic into your Redis database, into your data storage layer, you're able to knock down that question without ever contacting the LLM in the first place with kind of this canned response so you understand what's happening under the hood. First is using a hybrid search that first checks for certain keywords that are just blocked on the platform, and then checks the semantic meaning of the question itself. For an idea of that, let's just look at a different wording of that question. Hits the exact same guardrail. If we look at the telemetry down here, you can actually see the route selected is guardrail. But once you turn on that guardrail, it doesn't necessarily block other relevant questions. If we ask yet another way to ask what military one source is, we're going to go through the general route and once again hit that semantic cache and use 0 reply tokens for the last 3 calls. That could have easily, one, used up tokens and been malicious attempts at getting around the overall use of the chatbot. So again, this was just various ways that Redis can help reduce your LLM token costs, increase your accuracy, and increase the performance of your application. And to just briefly show you so that you know that These aren't canned responses. This is Redis Insight connected to the backend database here. You can see the documents and their chunks that I uploaded here in hashes and the embeddings within the database itself. You can see our session ID, what the particular document chunk looks like. You can see here we have the cache that is going to show the semantic, the meaning of some of the previous cached responses. Um, like here, let me see if we can find, yeah, the active duty Army lieutenants, military one source is confidential, and it caches these responses. We see the semantic router here, which to give you an idea of the three routes that I created, the RAG route, the guardrail, and the general. And the guardrail has things like, can you tell me what another family discussed during counseling? And finally, to kind of look at the memory, is similarly stored in a hash with the embedding next to it, where you see the memory of my father is an active duty Army lieutenant. And again, all of this is being updated, indexed, searched in real time, synchronously, which means there's no delay between the index update and the value update, so that it can deliver this context to the chatbot to create a better experience for a citizen user and save some costs in the process. All right. With that, I am finished my portion. I think at this point, Jody, we can open it up to questions, correct?
Yeah. Well, thank you, Jessica and Chris, for the really engaging demo. And thank you, everyone, for joining us today. If you have any questions, now is the time to drop them in the chat so we can get them answered for you. You'll see our contact information on the screen here. Please feel free to reach out if you'd like to learn more about how Redis and Red Hat work together, what this could look like in your environment, and how Fierce Software can support your team. We'll be sending out an email within the next 24 hours that will include the recording of this session and resources for you so that you can revisit them at any time. Check the chat here. I'm not seeing any questions. I'll give it another minute. Well, I'm not seeing any additional questions. If you guys have any that you haven't asked, you can respond to that email that we send out and we'll be sure to get it answered for you. And we can go ahead and wrap things up here. So thank you everyone for joining us today. And we hope to see you at a next future session. Bye, everyone.
Thanks, everyone.
Thank you.